practice solving systems using Gaussian elimination. We'll start with this 2x2 system. Remember, the first step is to write the system as an augmented matrix. So that means we're going to take the coefficients of our variables, the 2 and the 3 and the 1 and the -5, and put them in a matrix, and the constants as well. 29, -5. So there's our first step. Now our task is to use our elementary row operations and transform this matrix into a matrix in row echelon form. Remember, a matrix in row echelon form needs to look something like this. Ones along the main diagonal and zeros beneath. Here's a 2x2. These can be any numbers. And here's a 3x3 system. Could look something like this. Ones along this main diagonal and zeros beneath. And these, again, will be some other numbers. In some cases, you may get a whole row of zeros, and they would always go on the bottom. Today, we're not going to do any examples that will look like this. But we will do some where we should transform the matrix into something that looks like this or like this. So let's start. So for this particular problem, we need this entry to become a 1. And we have a couple different ways to do it. We could simply divide this row by 2, but that would introduce fractions. And so I'm not as inclined to do that if there's an alternative. And there's a nice alternative for this one. Remember, one of our possibilities for working with these matrices and our elementary row operations is to switch 2 of the rows, interchange 2 of the rows. So if we do that, this 1 will become the entry on the upper left. So we're going to switch rows 1 and 2. So let's do that. So our matrix will now be 1, -5, -5, and 2, 3, 29. And it's nice to have this roadmap for somebody reading your paper, or for you if you're going back to check your work, so you can figure out what happened to getting from one matrix to the next. So now we have a 1 here. Our next step is to get a 0 beneath. So probably the easiest way to do that would be by multiplying this row by -2 and adding it to row 2. So here's what I'm saying. We're going to take -2 times row 1. We're going to add it to row 2, and we're going to place it in row 2. Let me move this down so you can see it. When you're combining row 1 and row 2, mathematically speaking, it must be placed into either row 1 or row 2. So here we go. You can do this in your head. If you need a piece of scratch paper, go ahead and grab one. If we were going to do this on our scratch paper, here's my row 1. It's 1, -5, -5. I'm just copying this down. And 2, 3, 29. There's my row 2. So we're multiplying this row by -2. So we would have -2, 10, and 10. And we're adding it to row 2. So that's 2, 3, and 29. And when we add those, we get 0, 13, 39. And we're going to place that into row 2. So here's our matrix. Row 1 stays unchanged. 1, -5, -5. And row 2 is now 0, 13, 39. And the more you practice it, the more you'll be able to do it without going to scratch paper. And so now we're here. We have a 1 and a 0 beneath. We need to make this a 1 next. Notice if we just divide by 13, we will have a 1 right here. So let's do that. Remember, multiplying by a row by a constant is one of our elementary row operations. So we can think of it as dividing row 2 by 13 or multiplying row 2 by 1/13. Either way, we're going to place that into row 2. So I have 1, -5, -5 for the first row, and 0. Now we're dividing this row by 13. 0 divided by 13 was 0. 13 divided by 13 is 1. 39 divided by 13 is 3. And now we have our system or our matrix in row echelon form. Once we have that, we can rewrite our system this way as x minus 5y equals negative 5 and 0x plus y equals 3. And now it's just a simple back substitution. X minus 5 times 3 equals negative 5. Solve that equation. So our solution is 10, 3. And remember, you can always check to see if it's an actual solution by substituting it into both equations and confirming that it makes them both true. Let's move on and solve a 3 by 3 system now. And here's the system we'll solve. 2x minus y minus 5z equals 19. X plus y plus z equals 2. And negative x plus 3y plus 2z equals negative 3. And again, we're solving using Gaussian elimination. So our first step is to write that augmented matrix. And I always take care, it's so easy, even in copying down the coefficients, to make a mistake with one of the signs and then spend a while trying to figure out why it didn't work. So now here we go. Our goal, don't forget, is to get the matrix written in row echelon form. There's our goal. Starting here, we want a 1 and then a zeros beneath. So there are numerous ways we could get a 1 here. You could divide this row by 2. Again, like the previous problem, that's not my go-to strategy because I would be introducing fractions. I like to see if I can avoid it and keep the numbers integers if possible. If I can't think of anything else, I would definitely divide by 2. But we have other possibilities. I could add these two rows together, row 1 and row 3. And put that in row 1. But even easier is just interchange these two rows, row 1 and row 2. If I can get the results by just interchanging two rows, that's what I'll do. So row 1 and row 2 will be interchanged. So I have 1, 1, 1, 2. 2, negative 1, negative 5, 19, and negative 1, 3, 2, negative 3. And let me just double check that I didn't make a mistake copying those down. And that looks like our next matrix. Our next step is to get zeros beneath. Now to get a 0 here, I'm going to multiply row 1 by negative 2 and add. So I'm going to do negative 2 times row 1. Ooh, I'm running a little too high. Negative 2 times row 1 plus row 2, and I'm going to write the result in row 2. Turns out I can take care of this entry at the same time, so why don't I? Notice I can make this a 0 if I add row 1 and row 3 together and write it in row 3. So we're going to do both of those things in this next step. So here we go. And if you need to, grab a piece of scratch paper. Let's see if we can do it. So keep row 1 unchanged. Now we're multiplying row 1 by -2 and adding it to row 2 and putting the result in row 2. So our result is going right here. So it's -2 times 1 plus 2 is 0. -2 times 1 is -2 plus -1 is -3. -2 times 1 is -2 plus -5 is -7. -2 times 2 is -4 plus 19 is 15. And now we'll move and do our next elementary row operation, which is just adding row 1 and row 3 together to get a 0 here. So 1 plus -1 is 0. 1 plus 3 is 4. 1 plus 2 is 3. 2 plus -3 is -1. And we have taken care of this first column. Next we move here. We need this to become a 1. And again, we have a couple of options. I don't want to involve row 1 in the elementary row operation because then I will lose my zeros because that isn't a 0 there. So I'm focused just on these two, figuring out how to get a 1 right here. So two possibilities. One is to divide this by -3. That would be my last resort, but I could do that. And the other is, notice just adding row 2 and row 3 together will give us that 1. So let's do that. So I have row 2 plus row 3, and we're going to put the results in row 2. So here we go. Row 1 is unchanged. So 0 plus 0 is 0. -3 plus 4 is 1. -7 plus 3 is -4. 15 plus -1 is 14. And row 3 is unchanged. My next step is to make a 0 here. Again, I'm not going to involve row 1 at all. Notice I can multiply row 2 by -4 and add. So let's do that. So we'll have -4 times row 2, add that to row 3, and we're going to put the results in row 3. So my first row is unchanged, 1, 1, 1, 2. And actually my second row is unchanged as well. And now here we go. We're figuring out row 3. We're multiplying this row by -4 and adding it to row 3. So -4 times 0 plus 0 is 0. -4 times 1 is -4, plus 4 is 0. -4 times -4 is 16, plus 3 is 19. -4 times 14 is -56, plus -1 is -57. Oh, my matrix isn't quite big enough there. And finally, I need one more step to put this in row echelon form. I need a 1 right here. So let's just divide row 3 by 19. So row 3 divided by 19, and we'll put that in row 3. So I will have, for my matrix in row echelon form, something that looks like this. I'm dividing by 19. 19 divided by 19 is 1, and -57 divided by 19 is -3. So I can now write the system that this matrix implies. It is x plus y plus z equals 2. y minus 4z equals 14. And I'm going to move it over so you can see it. And z equals -3. And now, excuse me, we're going to do back substitution to find the solution. So we have z equals -3. Pop that into y minus 4 times z equals 14. So we have y equals 2. So we have our z value, we have our y value, and we'll find x. Substituting it into the first equation, we have x plus y plus z equals 2. So we get x equals 3. So our solution to this system, remember we started with this system right here, our solution will be 3, 2, -3. Make sure you write it in the correct order. It's x, y, z, since it's an ordered triple. And we're going to do one more. So here is our 3 by 3 system. And at each step, see if you can think about what elementary row operation you would choose to do as we move through this problem. So we start with our matrix. So we have 4, 3, -9, 25, 1, -1, -2, -1, and 2, 0. Notice there was no y here. 5, -3. So here's our augmented matrix. I hope you see that switching those two rows will easily give us the 1 as the first entry. So I'm going to write row 1 and row 2 are being switched. So my matrix looks like this. 1, -1, -2, -1. 4, 3, -9, and 25. And 2, 0, 5, and -3. So the first entry is taken care of. We have a 1 right here. Remember, next, we want to get zeros beneath. And remember, we can take care of both of those terms at the same time. So I'm going to multiply row 1 by -4 and add it to row 2. Write that down. -4 times row 1 plus row 2. We'll put the result in row 2. And I'm going to pull this down so you can actually see what I wrote. And then we'll multiply -2 times row 1 plus row 3. And we'll put the result in row 3. So we're going to make both of those zeros at this step. So here we go. Remember, row 1 is unchanged. And now here comes our arithmetic. Here we go. -4 times this row. And again, if you feel better doing it, grab some scratch paper. So -4 times 1 plus 4 gives us 0. -4 times -1 is +4, plus 3 is 7. -4 times -2 is 8, plus -9 is -1. -4 times -1 is 4, plus 25 is 29. And now we'll move to this row. We're multiplying by -2 and adding it to row 3. So -2 times 1 is -2, plus 2 is 0. -2 times -1 is 2. 2 plus 0 is 2. Negative 2 times negative 2 is 4. 4 plus 5 is 9. We're multiplying by negative 2. Negative 2 times negative 1 is 2. Plus negative 3 is negative 1. And our first column is taken care of. Our next goal is to have 1 for the entry right here. Now this one we may have to be a little bit trickier if we want to avoid fractions. I always consider it a game to see if I can avoid fractions and keep things as integers. If I can't, then I go ahead and divide and introduce fractions into it. So for example, we could divide this row by 7, and that would make this a 1. That's not really my choice. We could divide this row by 2 and switch them. If I were going to introduce fractions, that's what I would do. But I'm thinking about some kind of combination between rows 2 and 3. Remember, we're not involving row 1 in this at all. We're not even thinking about row 1. I'm focused on these two. I have a 7 and a 2. And I'm thinking about multiples of row 1 and multiples of row 2, thinking about how I could get a 1. And notice, if you multiply row 3 by 3, you would get a 6 here, and then we could subtract, and that would get a 1. Those are the kinds of things that I look for. So we're going to do this. Row 2 minus 3 times row 3, and we're going to put the result in row 3. So it's this row minus 3 times this row. And we're going to put the result, oh, I said in row 3. It's actually going to go in row 2 because our goal is to put a 1 right here. So let's do it. Row 1 is unchanged. And here we go. This row minus 3 times this row. So you might think it is a little bit easier if you do negative 3 times this and add in this number. So negative 3 times 0 is 0, plus 0 still gives me the 0. Negative 3 times 2 is negative 6, plus 7 is 1. Negative 3 times 9 is negative 27, plus negative 1 is negative 28. Negative 3 times negative 1 is 3, plus 27 is 32. So that's what we just did. And let's just bring down our third row. Do I have room right here to do another iteration? Let's do it. So now we need a 0 right here. We're going to multiply row 2 by negative 2 and add. So negative 2 times row 2. To get a negative 2 here, we're going to add it to row 3. And we're going to put the results in row 3. So here we go. Let me see if that should fit. So leave row 1 unchanged. Leave row 2 unchanged. And I'm getting a 0 right here. So here we go. Negative 2 times 0 plus 0 is 0. Negative 2 times 1 is negative 2. Plus 2 is 0. Negative 2 times negative 28. And you could grab a calculator. You get 56. 56 plus 9 is 65. And negative 2 times 32 is negative 64. Minus 1 is negative 65. And we're here. Almost in row echelon form. Our last step is to get a 1 right here. So we're going to divide row 3 by 65, and we'll put the result in row 3. And again, I wrote where you couldn't quite see it. So our row 1 is unchanged. Our row 2 is unchanged. And we're dividing by 65. So we have 0, 0, 1, negative 1. And our matrix is in row echelon form. So now we can write our system as x minus y minus 2z equals negative 1. Y minus 28z equals 32. And z equals negative 1. And we can do back substitution to solve the system. We know our z value. Let's find our y value. Y minus 28 times negative 1 equals 32. Solve the equation. And we get y equals 4. And back substitute both of these into this equation, and we have x minus y, which is 4, minus 2 times z, which is negative 1, equals negative 1. Let's do some arithmetic here. We have a negative 4 and a positive 2. Negative 4 plus 2 is negative 2. And we add 2, and we get a positive 1. So now we can see our solution to our system. The solution to this system over here is the ordered triple 1, 4, negative 1. And I hope you'll go practice solving some systems using Gaussian elimination.